in this section I want to talk about some path preference mechanisms in Ospf. So let's go to router 1. I want to check something and see how can I reach to one of my router's loopback interfaces. For example, I am in router 1 and I can reach to router 4 through two different ways. One is router 2 and the other one is router 3. I want to make sure that I receive the path from both of these, because if I do not, I will not be able to configure what I am going to do. So let's go to router 1 and here type show IP Ospf database, and by typing this I should see that for 100.100.4.4 I have two different values. Now let's find 100.100.4.4. You can see that I am receiving this from router 3 and not from router 2. So if I check my routing, I can see that the only path is 100.100.3.3. That's going to be router 3. So I can only reach to router 4 from router 3. So there should be a mechanism to filter this out. I should go to router 2 and find out this. Show run section router Ospf, and I guess I have a filter here that says area range, and this is why I do not see anything from router 3. I want to remove this, so I go to router Ospf. Let me type this router Ospf1 and remove this command like this. Now by removing this, I can go to router 1 and check the IP Ospf database again, and now I should see that yes, now I can receive this from router 1 and router 2. That's what I'm going to show you. Okay, now on router 1 I receive this from two different ports, from two different exit points. So how can I prefer one to the other? Let's see which one is preferred right now. Show IP route to 100.100.4.4 gives me two different routes. The preferred one is the first, that goes through router 3. So if I check the metric, it tells the metric is 3. The other one has a metric of 3 as well, but as you can see, this is the best one. And actually, because I see traffic share count as 1, that means that I have installed both of these in my routing table, and by installing both of these I can use both of these links as some kind of load balancing. Okay, what I'm going to do is to prefer one of these to the other. I want to prefer 110.10.10.12 to the route that goes through router 2 to router 3. How can I do this? I can achieve this goal using different methods. One of them is to change the bandwidth. Bandwidth is what Ospf uses to calculate the metric. I'm not going to change the bandwidth because other processes on this router may depend on the bandwidth that is configured on the link. I'm not going to change that. What I'm going to do is to change the Ospf feature, and for this I need to go to router 1. I need to go to interface path 00 that is connecting to router 3, and here I have an IP Ospf cost command that I can use to assign a warehouse value for this link, for example 1000, and hit enter. Now if I check IP Ospf interfaces in brief, this tells me that I have a high cost on path 00, so this is not going to be preferred by calculating the values. So let's check this IP route again. By checking this, I can see that the only path installed is path through router 2. So what happened to the path that came from router 3? Let's check show IP Ospf database, and here I see that the path is still there. You can see that this is the path and the age is quite okay and everything is just fine, but let me get some more information about this. By going to show IP Ospf database, this time I'm checking the summary for this, and now you can see that I have two different paths, but one of them, the one that comes from router 2, has a metric of 2. This is a metric that router 2 actually you know, advertises to me. The other one again has a metric of 2, so this is what router 3 advertises to me. But here, because I have a high cost configured on the path to router 3, actually the ABR, this is why I do not select that. So this is an inter-area selection. Router 1 selected to go this way. That's because the path to router 3 has a high cost, so it is not going to use that. So using IPOSPF cost command is a very, very nice feature to control the way that you send your traffic, control the path actually that you send your traffic. Nice. I want to remove this. I don't want to have this high cost here. What I'm going to do here, I want to show something that affects the whole OSPF process. I can go to Ospf process here, and here I have a command that is let me find. That's the command. Where are you? The command? I cannot find it. That's here. Autocost. Autocost. It says with this value you can change the way that you are calculating the bandwidth. Actually, if I show IP protocol, when I have Ospf in place, I can see that the value for the baseline is 100 megabit per second. That means, let me show you. If I have a link with 100 megabit per second bandwidth, its cost is going to be 1. If I have a gigabit on one link, again the cost is going to be 1. But if I have, for example, a 10 megabit per second link, the cost for that is going to be 10. That's because we are actually dividing 100 by 100. That yields 1 here. We are dividing 100 by 1000. That yields 1 again here. And this is the list. Actually, it is not going to be 0.1. It is 1. That's because Ospf is going to round it up to 1. But here, if I divide 100 by 10, the result is going to be 10. So this cost is higher than this cost. That's because the bandwidth on this link is lower than the bandwidth on the other link. So I will suppose that I want to change the reference bandwidth. The reference bandwidth here is 100, but I want to make it 1000. That's because I want to have a better calculation, because my links are gigabit links or even 10 gigabit links. So what I'm going to do is to change this reference bandwidth. When I am changing this, I will go for a higher value. And let's go and do this. Here I want to go to router configuration, and I type autocast, and here we have reference bandwidth, and it tells me that I should change the reference bandwidth and I should enter a value in megabits. So I type 1000 megabits or even 10,000 megabits, because I may have 10 gigs for some of the links. So that's going to be my reference bandwidth. And when I hit enter, it gives me a warning. It tells me that I have changed the way I calculate the metrics on this router, but you should have this consistent on all your routers. So you should go for all your routers and change this value on them. But I'm not going to do this. So let's check IPOSPF interfaces in brief and see the result right now. You can see that my fast interfaces are 100 megabit per second. Now I have 10,000 here. If I divide 10,000 by 100, the result is going to be 100. So the cost on fast Ethernet interfaces now is 100, opposing to what we had previously. And now I have a metric type that I can calculate. I can assign even a meaningful value to the gigabit interfaces. So as I told you, you should do this on all your routers if you are going to have a uniform configuration on all of them. Here I just did it for the purpose of demonstration. Okay, I remove this. So what I'm going to do in next section, let me see what we have here. In next section I should go and talk about different OSPF operations.